Hello students, welcome back. Let's go to problem 2. Problem 2 is, as a matter of fact, a continuation of the previous problem. It's based upon the same study, same statistics. The article, Development of Novel Industrial Laminated Planks from Sweet Gum Lumber, Journal of Bridge Engineering, 2008, volume 64, 66, describe the manufacturing and testing of composite beam designed to add value to low-grade sweet gum lumber. These are the sample statistics. And here we go. Sample size of 30. That means tested 30 times. And then the mean is 7,203.091 pound per square inches. And the standard deviation was 542.540. And then here's a question. Does the sample statistics suggest the mean modulus of rupture exceed 7,000 psi? Let's look at the mean. Does it exceed 7,000? Yes, it does. If it is no, then there's nothing to do. You can simply say no and then just walk away. But it's bigger, which means we need some work. We got 7,203.091, but it is significantly larger than 70,000 based upon the standard deviation and the sample testing, or not. It's close enough so that you'll have to assume it's pretty much 7,000, not more than that. Who knows? Let's test it. Let's set up the hypotheses. The null hypothesis is pretty much straightforward. The real mean is about 7,000, and that's explicitly given. Now, alternative hypothesis, almost always, it should be greater or less. How do you tell it's greater or less? 7,200 something. Hey, that's greater than 7,000, so it should be mu greater than 7,000. Now, I'm using approximate equal, a little bit better than just equality sign, of course, because nothing is precise in statistics. And even more, not just inequality, but double inequality to represent significantly bigger than 7,000. Statistically meaningfully bigger. Our textbook author just uses this usual inequality, and I'll tolerate it. I don't like it very much because if you use just usual inequality, that's fine because it's handwriting, but textbook is in print, so it should be better, but I'll tolerate it. A warning though, this is correct null hypothesis, and I haven't seen many people making mistake here. As for alternative, however, I've seen far too many people making this mistake. This is wrong. Null is correct, but alternative is not right. You don't use this as a hypothesis. This is coming from sample. Hypothesis must be coming from the problem itself. So this is wrong. And it should be an inequality. 7,203.091. Is it greater than 7,000? Oh, yes, of course. That's why you are selecting significantly greater as your alternative hypothesis. Okay, let's go. Let's go and test this hypothesis. And we have various different methods. And the first method I'm going to talk about is the critical value method, my favorite, and it's not the easiest to calculate, but the easiest to understand. Step 0. Is it a t-test or z-test? It's a t-test because the original distribution is believed to be normal. Yeah, it's coming from observation. The original standard deviation is unknown. It's not sigma, it's S, coming from sample standard deviation. But in this case, it's an observation, so it's unknowable. And finally, the most important, the sample size is small. We have just 30 and which is way less than the usual threshold of about 100. By the way, some really old textbooks use the threshold as 30, but that's really old. That's because many people were just copying the previous textbook, which was copied from the previous, which goes on for 50 years. And that was before the advent of all those computing tools. And that's why people are still using 30. You should not be using that. Nowadays, the expectation for accurate computing is much higher than what it had been 50 years ago. So n equals to 30 is definitely small sample nowadays. I usually use a threshold of 100, but depending upon author, sometimes you may go even further. Anyway, we have to use t-test, and then hypotheses we just went through already. Null, about 7,000. Alternative, much bigger than that. And the sample statistics, okay, and it's the same as those. Please check. Same as those, right? Okay, all right. And then here is the initial picture. Let me copy and paste the sample statistics. Okay. And then we draw the outline. And then the center is, of course, the null, 7,000. Maybe I should be opening, no, not this one. This one as well. In that case, I cannot bring everything in the same viewing window. Let's see, okay. Let's put it over here. All right. Okay, null is 7,000, and that's the center. And then we're looking for 7,200 something. That's bigger than 7,000, isn't it? So we have to go to the right. So 7,200 something may be here in blue region, which is considered close enough to the null, so null wins. Or it could fall into the red region, too far away, so that alternative wins. Okay, that's the idea. So if you find out this threshold or the critical value, then we can compare that with absolute mean of 7,203. You can determine whether this X bar falls into blue region, null wins, or the red region, alternative wins. That's the strategy. Okay, all right. Let's go to the next step. Let's do some computation here. And let's find out the critical value. Maybe I want the picture again. I want this critical value, X value here. That's what you're looking for. And let's calculate it out. End minus center over SE, our bread and butter. End minus center. End is X, of course, and center is 7,000. So X minus 7,000. How about standard error? Standard deviation over square root of n. What is the sample statistic? Did I erase it already? Oh, never mind. Let me copy and paste it again. Okay, all right. This is standard deviation observed from the sample and divided by square root of n, and that goes to the denominator. And that should be associated to t-score, associated to the situation. And did I say alpha is 0.05? Yeah, okay, let's go to the t-table and let's look for degree of freedom of 29, because sample size is 30. Okay, it's already highlighted in there. And then 0.05, alpha value, this value of 0.05. Okay, 0.05 here. Let's go to that column. And I get 1.699. Do you see it? 1.699. So we get this equation. Let's solve it. Flip this denominator to the other side by multiplying. So we get 1.699 times that, and then flip over this subtraction, we get 7,000 plus, and we have this. Calculate your calculator. We got 7,168.292 approximately speaking. That is the threshold. Let's go back to the original picture. 7,168 there. Once you find out this, you can easily test where this mean X bar falls. And that's the next step. You calculate this critical value in 7,168. Now it's easy to test where does the observed mean fall. A little bit to the right, because 7,203 is bigger than 7,168, so it falls in the red region. Too far away from the null. Null is right over here, 7,000. This is threshold, critical value. It's even farther away. So who wins? Null, blue, alternative, red. Red wins. Alternative wins. So we reject null and accept alternative. And so much for the critical value method. In the next video, let's talk about the probability value method.